There are 8 types of ACLs. These types are standard numbered, standard named, standard numbered with the sequence editing feature, standard named with the sequence editing feature, extended numbered, extended named, extended numbered with the sequence editing feature, and extended named with the sequence editing feature. To create and configure these access lists, we have 2 commands. These commands are access list and IP access list. The main difference between both commands is the first command supports only 2 types, the standard numbered and extended numbered, while the second command supports all 8 types. Let's understand the arguments, options, and parameters of both commands. This is a global configuration mode command. This command allows us to create a standard numbered ACL and an extended numbered ACL. This command uses the following syntax. Let's discuss this syntax. It is a numerical argument. The router uses this number for the following purposes. To identify the protocol that will use the ACL to filter the traffic. To identify whether it is a standard ACL or an extended ACL. To group all the statements in the ACL. The ACL specifies a range of numbers for each network layer protocol. For the IP protocol, it specifies the following ranges. From these ranges, the ranges 1 to 1999 and 1300 to 1999 are used for standard access lists, and the ranges 100 to 199 and 2000 to 2699 are used for extended access lists. To create an IP access list, you must specify a number from the predefined number ranges. For example, to create a standard IP access list, you can choose any number between 1 to 1999 and 1300 to 1999. Similarly, to create an extended IP access list, you can select any number between 100 to 199 and 2000 to 2699. While selecting a number for the ACL, you must follow the following 2 principles. To create a new ACL, use an unused number from the range. If you use an existing number, the router will append the ACL related to the specified number. If you are using Cisco Packet Tracer to practice ACL-related topics, you should know that Packet Tracer includes only essential ranges of numbers for the IP protocol. It does not include the extended range of numbers. To view or use all ACL numbers, you can use GNS3 or a real router. As you can see here, GNS3 includes all ranges for all protocols. It is not a bug or an error in Packet Tracer. It is a feature that allows Packet Tracer to run multiple devices on less hardware configurations. Packet Tracer simulates networking devices. In the simulation process, the software includes only the required features and functions of the physical device and the virtual device. Packet Tracer was mainly developed for students. It includes all features and functions that you need to practice CCNA exam topics. For example, you need extended ranges only when you want to create more than 99 standard or extended ACLs on the same router. No CCNA exam topic requires you to create more than 99 standard or extended ACLs on a single router. If you want to create a complex network with hundreds of ACLs on every router, you can use GNS3 or real routers. No matter how many ACLs you create on a router, they all use the same configuration style. Let us specify an ACL number to view the next parameter. The next parameter in the command syntax is an option with 2 values. If you use the permit option, the router will allow the packet that matches the condition defined next to it. If you use the deny option, the router will block the packet that matches the condition defined next to it. The next parameter is the conditions. The router uses conditions to match the packet. A standard ACL and an extended ACL use different criteria to match a packet. The available options in this section depend on the value of the ACL argument. If you have specified a number that belongs to the standard ACL, the command will use the following syntax. If you have specified a number that belongs to the extended ACL, the command will use the following syntax. Let's first discuss the criteria of a standard access list. We have already discussed the options and arguments till the action option. Now, let's discuss the remaining arguments and options. Source IP address. It is an argument. It accepts the source address. You can use a host address or a network address. If you use a host address, the router will match that particular host. Or if you use a network address, the router will match all hosts of the specified network. Wildcard mask. It is also an argument. It allows us to define the type of the source address. You can define a particular IP address or a range of IP addresses. Log. It is an optional parameter. If you specify this parameter, the router will print any match of this statement on the console port. By default, the router does not print log messages on a non-console connection. We have discussed the criteria of the standard access list. Now let's understand the criteria of the extended access list. Unlike a standard ACL that supports only the source address, an extended ACL supports many options in the condition field. An extended ACL allows you to filter traffic based on supported IP protocols. The options available after this argument depend on the protocol you select. For example, if you select the IP protocol, you will see the options for the IP protocol. Or if you select the TCP protocol, you will see the options for the TCP protocol. CCNA exam syllabus includes 4 IP protocols. These protocols are IP, TCP, UDP, and ICMP. Before we discuss the options of these protocols, let's understand the type of filtering. There are 2 types of filtering: host-level filtering and application-level filtering. Host-level filtering is used to filter all the traffic from the host. Application-level filtering is used to filter specific traffic from the host. For example, if you want to filter all traffic from a host, you would use host-level filtering. But if you want to filter only web traffic from the same host, you would use application-level filtering. In simple terms, host-level filtering checks whether host A is allowed to access host B, while application-level filtering checks how much host A is allowed to access host B. Let's discuss how to configure both types in detail. To filter all the traffic from the host, we use the IP address of the host. To use an IP address, we need to specify the IP keyword here. The IP keyword instructs the command that we want to filter the traffic based on the host address. After the IP keyword, we have 2 fields to specify the source address and the destination address. We can specify a single host address or a range of IP addresses in both fields. We can use wildcard masks with both addresses. To filter a specific type of traffic coming from a host or going to a host, we use the name of the protocol that transports the traffic. On an IP network, an application can send its traffic by using one of 2 protocols. These protocols are TCP and UDP. To filter traffic based on an application, we use the following syntax. Both protocols can simultaneously transport data of many applications. Both protocols use a unique number for each application to keep its data separate from other applications. These numbers are known as port numbers. Both protocols use different port numbers for applications. For the CCNA exam, you should know these port numbers. The established keyword allows traffic to pass through only if it is generated from inside. It is used only with TCP packets. With this keyword, we can control the direction of the data flow. If we use this keyword, the ACL will allow only those TCP packets which have the established flag bits set in their header. The log keyword instructs the router to log a message every time an ACL entry is hit. As I mentioned earlier, for the CCNA exam, you should know how to filter traffic of 4 protocols. These protocols are IP, TCP, UDP, and ICMP. We have already discussed IP, TCP, and UDP. We use the IP protocol to filter host-level traffic. We use TCP and UDP protocols to filter application-level traffic. Now let's understand the ICMP protocol. To filter ICMP error messages, the command uses the following syntax. If we do not specify a particular message type, ACL will match all message types. The following table lists some of the most common ICMP messages. You can create an access list in 2 styles, classic style and modern style. The classic style does not support the editing feature. The modern style supports the editing feature. If you use the classic style to create an ACL, you will be able to append it, but you will not be able to modify it. If you use the modern style to create an access list, you will be able to append, edit, and modify it. The classic style uses the access list command. The modern style uses the IP access list command. Just like the access list command, the IP access list command is also a global configuration mode command. It uses the following syntax. This option specifies the type of ACL. To create a standard ACL, select the standard option. To create an extended ACL, use the extended option. To create a standard access list, use the following syntax. To create an extended access list, use the following syntax. The next parameter specifies the number or the name of the ACL. The router uses this number or name to group all statements. Instead of using a number, you should use a name here. A clear and descriptive name makes ACL management easier. For example, suppose you find an ACL 126. The number 126 does not tell anything about the ACL. But if you find an ACL with a name like block sales, you can easily guess the purpose of the ACL. Let's take some examples of this command. To create a standard ACL with the number 34, we will use the following command. The following command creates a standard ACL with the name block production. The following command creates an extended ACL with the number 136. To create an extended ACL with the name allow HTTP traffic, we will use the following command. The access list command and the IP access list command use the same options to build and add an entry to the access list. We have already discussed these options in detail. Let's understand the main differences between the access list and the IP access list command. Both commands use different configuration styles. The access list command uses a flat configuration style. It uses a single syntax to create and manage an ACL and the ACL's entries. It can create only numbered ACLs. You can only append numbered ACLs. You cannot use it to edit ACLs. The IP access list command uses a hierarchical configuration style. It uses different syntaxes to create and manage an ACL and the ACL's entries. It creates and manages ACLs in global configuration mode. To manage ACL entries, it uses sub-configuration mode. You can use it to create and edit both the numbered and named ACLs. That's all for this video. If you have any suggestions, comments, or feedback about this video, please share them in the comment section given below.